Hi everyone, this is a short video showing a summary of my work for my final project in DA5030. The dataset I used is called the Contraceptive Method Choice dataset, and it can be found in the UCI machine learning repo, shown here. This data was collected by the Indonesian government in the mid-80s. After doing a bit of research on the topic, I found that a program in Indonesia called the Family Planning Program set out about 40 years ago to control the growing population in order to increase the economy's growth and decrease the efforts on addressing the problem attributed to an overpopulation in a developing nation. Through the 70s and 80s, the Family Planning Program decreased the number of children per family from over 5 to about 2.6. This was attributed to more widespread adoption of contraceptive methods, with the mean age of contraception used decreasing. In the past decade, the program efficacy has decreased. At a summit in London in 2012, the government vowed to reach a rate of 2.1 children per woman by the year 2025. Though this data that was collected here is a bit outdated, it can give us a look into the factors that are most important in a woman making a decision about her contraception choice. With limited resources, it's important to investigate and hone the efforts of the government on the factors that hold the most weight, and ultimately making a decision, therefore making the government's goal a reality. This dataset collected demographic information from married, non-pregnant women. So we can see here that the study collected information about a wife's age, their education, their husband's education, the number of children they have, their religion, whether they're currently working, their husband's occupation, their standard of living index, and their level of media exposure. In addition to the factors that I just mentioned, the study also collected whether each woman was using no contraception, a short-term contraception choice, or a long-term contraception choice. Rather than using these factors to try and predict what kind of choice a woman will make, the goal of analyzing this dataset is to investigate which of these factors actually hold the most weight or are most important to a woman's decision. If we can find a few factors for the government to focus on, it will allow them to reach their goal of decreasing the fertility rate. For example, in this dataset, there were 1,473 women interviewed. Of those, there are 629 who have chosen to forego a contraception choice altogether, 333 that use a short-term choice, and 511 that choose a long-term choice. If we find that media exposure, for example, is an important factor in making this decision, for example, maybe all of these 629 women who have chosen to forego contraception have a low level of media exposure. Well, that would indicate to the government that media exposure is an important factor in making a decision, and they can start to focus their efforts on increasing accessibility to media exposure. The first thing I did to look at some exploratory points in the data was to look at the distribution of the data sets. So the two factors that I chose to look at were the wife's age and the number of children they had. These were the two numerical factors in the data set. So first I just made a histogram of the wife's age, and you can see from the graph that it's a little bit skewed to the right. For example, we see that the mode is around 25 here, but when we look at the mean and the median, they're both around 32. And same thing goes for the number of children. So when we plot the graph of the number of children, we can see that the mode is just around 1, the most number of children, and when we look at the mean and the median, they're both around 3. So, and then I looked at a square root transformation of both of these attributes. So when we perform a square root transformation on the wife's age, we can see this plot. It looks like a much better normal distribution. The mode is right around 5, between 5 and 6. And when we look at the mean and the median, also right around between 5 and 6. And lastly, when we look at the square root transformation of the number of children, we can see from the graph that, again, the mode is right around 1 and 2, and the mean and the median are both right between 1 and 2. So these log transformations allow the data to have a much more normal distribution. Most of the models that I chose don't care about the distribution of the data, but this is a good piece of information to know moving forward in case we did choose to pick a model that did care about distribution. The next thing I looked at to explore this data was to see if there were any outliers. So first, I actually found the outliers by looking at z-score. So first I found the z-score for the wife's age. The reason I chose the wife's age was when I was just looking at summaries of the data, it looked like there was a pretty wide distribution of the ages that the data collected information from. So if we run this line right here, this will give us the z-score of the women and just create a new column in the data set. And then I filtered out anything that had a z-score, filtered for anything that had a z-score of anything greater than 1.5 or less than negative 1.5. And we can see for the outliers, the youngest women who they interviewed were around 16 and 17 years old. And we can see that there are two standard deviations away from the mean. And when we look at the other end of the outliers, we see that the oldest women that they interviewed were 49 years old. And again, about 2 standard deviations away from the mean. And if we just look at the mean age of the information collected from the women was 32. So because there was no error reported in the collection of this data, I chose to keep the outliers. I chose not to remove this piece of data. So this data needed to be cleaned a little bit before I could move on with my analysis. So if we just look at a summary of this data, we can see that everything is numerical in nature. However, that is not the case. For example, the only attributes that are numerical are the wife's age and the number of children. Everything else is either a binary option, so something like religion, which was a yes or no about whether or not the women were Muslim. Pretty much everything else needs to be transformed to a factor. So things like education was an option, a value 1 through 4, depending on the wife's level of education. Same thing for husband's education, husband occupation, etc. So in order to clean this up, I used as factor on all of the attributes that should have been categorical in nature, but were being interpreted as numerical. So if we run this will transform our values. And next, the options that were not binary in nature, so things like the wife's education, the husband's education, their occupation, these needed to be transformed to a dummy variable. So these lines right here will take care of that for us. And then the last thing I did to clean up the data was to normalize the wife's age and the number of children. So I chose to use min-max normalization. The reason being was because the wife's age and the number of children are on very different scales. So I didn't want either to be interpreted as having more weight or being more important and incorrectly influence the data. So if we run our function to normalize the data, and then use that function for the wife's age and the number of children, this will replace those values with the normalized values. Next, I combined all of the edited columns that we just created. And finally, I had to reconvert all of these to factors one more time. So that will do that for us. And then if we just look at our clean data here, we can see that we now have dummy coded columns for each of our categorical values. So wife education, like I mentioned before, husband education, etc. Things like the wife's age and the number of children we can see are now normalized here like we wanted. The wife religion, we are expecting only one column. I mentioned before that it was a binary option. So this all looks good and we can continue with our analysis now. So next I'm going to go into a little bit about the models that I chose and why. So the first one that I chose to look at was a decision tree because of the transparency in the decision making. So as I mentioned before, the ability to predict a woman's decision is less important than knowing the weight that each of these factors holds in ultimately making the decision. So decision trees allow exactly that, by providing a good visual of what factors play the biggest role in the outcome. So additionally, decision trees can handle both numerical and nominal inputs, which this data set had both of. And they don't care about the distribution of the structure, which kind of takes out a level of complexity. We did look at the distribution of our data, and though the decision tree doesn't care, it's good to know. So before I ran any of the models, I first created a training and a testing data set, so we can see that the training has most of the data and the testing has 15%, or sorry, 20% in this case. And then if we run the decision tree model generation, and then we can actually plot the output, or we can plot the decision-making process. And we can see the biggest splits in the data. So the first split is the number of children, then the wife's education, and the wife's age. So we can, just by visually looking at the decision tree model, we can see that these are the three biggest factors that play a role in a woman's decision to make a contraceptive choice. So the second model I chose to look at was random forest, for very similar reasons to the decision tree model. The transparency is a big deal in the decision-making process. Again, the reason I didn't choose any black box methods, something like a neural network, is because you can't see why you have the outcome that you have. Ultimately, the goal of the Indonesian government is to decrease their fertility rate, and knowing the reasons of why each of these factors is important in the decision will help them achieve their goal. So we can run our random forest model here to generate it. And then we can actually plot our random forest model similar to our decision tree. And we can see that similar to the model that we just looked at before, the top three factors that play the biggest role in making the decision are the wife's age, the number of children, and the wife's education. So it's in alignment with the outcome of our decision tree. And finally, the last model that I chose was naive Bayes. The reason being is that because it performs well with categorical data. One downside to the naive Bayes is, in relation to the data set, is that it assumes each feature is independent. And we looked earlier with our collinearity analysis. We saw that some of the factors did have high correlation rates with one another. So this might cause a problem, but we can take a look. So if we run our naive Bayes model, we can then use this predict function to create predictions using the model based on our training data set. And then we can look at a confusion matrix, and we can actually look to see that the accuracy is pretty low. This might be due to the collinearity, it might be due to multiple factors. But again, like I had mentioned before, the predictive value, the predictive ability of these models is not super important. It's more important to look at how the decision is being made. So finally, we'll take a look to see how these models performs in comparison to one another. So I chose to look at RMSE. The reason being was because I wanted a metric that would simply compare the models rather than finding something like absolute accuracy. Reason being was because the goal of the government was not to be able to predict. So looking at accuracy would be looking at how well these models were able to predict the outcome, which is not what we were interested in. So if we look at the decision tree model, we can calculate the RMSE, and we can see that it's 1.079. And then we can also take a look, at the random forest. And it's pretty similar, 1.08, they're very close to one another. The decision tree performing just slightly better. And finally, we can look at naive Bayes, and it's just a little bit higher, 1.16. So like I mentioned before, that might be due to the fact that it assumes independence in the data set, and there are some factors that have a high collinearity, they have high correlation. So that could be the reason why the naive Bayes performs slightly worse. And then finally, I did create a stacked ensemble. So I basically combine these three predictive models, and I then trained them using the random forest method, which you can see here. And then I found the RMSE of the stacked ensemble, which actually does perform the best. We can see that the RMSE is the lowest here with the stacked ensemble. Based on the models created that I showed, we can use the decision tree and the random forest models to make a few decisions that the Indonesian family planning program could use in order to achieve their goals. While machine learning models can be used for either decision making or predicting, in this case, decision making and understanding were far more important than predicting because of the goals set by the Indonesian family planning program. With limited resources, it's critical for efforts to be distributed in a way that will be most effective in reaching the goal of the decreased fertility rate. Upon inspecting the decision tree model graph, we can see that a major deciding factor of whether or not a woman will choose to use a long-term contraception is based on whether or not they already have a child. Wives that have not yet had any children will almost always decide to forego contraception. Next, we can see that education is another key split. Those with lower levels of education are less likely to be using long-term contraception than those who are more highly educated. And finally, age plays a big role in the decision-making process for younger women, or for these women in general. Younger women are more likely to choose not to use a long-term contraception choice, or any contraception at all, than older women. The plot from the random forest assessment also confirms the findings that these three factors are the most important demographics to target for the Indonesian government's efforts. Based on these findings, it would be best if the contraception choices were taught and communicated to younger women, especially those who are considered to be less educated. Maybe there are pockets of villages or locations where education is lacking. These areas could be explored first. Next, the information regarding contraceptive choices should be taught at a younger age to provide women with the necessary information early enough to make an informed decision regarding long-term planning rather than finding options when it might already be too late. Finally, we saw that women who have not yet had any children are more likely to not use a long-term contraception option. This may be due to the fact that they haven't had children yet, or because they are younger. This demographic is a bit more difficult to target specifically. However, I think by starting with younger, less educated women, the government would effectively cover the demographic of women who have not yet had a child. These actions would help the government reach their target fertility goal by their set timeline. Thank you all for listening.